Good afternoon, and thank you for joining today's webinar from Spec Innovations, Verification and Validation using Innoslate. My name is Sarah Craig, and I will be the moderator for today's webinar. Let's go over some quick housekeeping before we get started. For those of you who may not be aware, Spec Innovations provides systems engineering services and solutions to the aerospace, defense, and intelligence communities. Our flagship software, Innoslate, provides users with an all-in-one systems engineering software solution with requirements management, analytics, modeling, simulation, and analysis of alternative tools. We help organizations securely collaborate on critical projects throughout the product or systems lifecycle. During the presentation, feel free to send us questions using the panel on the right, and we will get them answered in the question and answer part of our webinar. The webinar is being recorded, and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now, I would like to introduce you to our presenter, Dr. Steve Dam. Today, he will be showing you through the features in Innoslate that implement verification and validation. Dr. Dam is the president and founder of Spec Innovations. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam participated in the development of C4 ISR Architecture Framework and DoD Architecture Framework, DODAF. He has also received an Expert Systems Engineering Professional ESCP certification from NCOSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. And now I will hand over the controls to Dr. Dam, and we will get started.
I'm off mute. There we go. Thank you, Sarah. Appreciate it. Thanks for the intro, and let's just jump into today's presentation. So, give you a little bit about V&V in the early stages of the life cycle. Actually, a tremendous amount of work gets done early in the life cycle if we're doing this right, which sometimes we don't. And then preparing for V&V, talk about applying the lifecycle modeling language to verification validation, talk about verifiable requirements, and also developing the V&V plan using MVSE. So V&V in the early lifecycle stages. So we'll talk a little bit about, kind of ground set everybody with what are we already talking about in terms of V&V, what do we mean by that, and then how is it used throughout the cycle. So first, V&V, you've probably seen these definitions. These are the Google definitions, which are pretty good. A process establishing the truth, accuracy, or validity of something. And so the validation is the action of checking or proving the validity or accuracy of something. So again, verification validation by these definitions almost look the same. They're very highly overlapping in the thought. With U.S. government work, we've really taken these to have much more specific meanings. In particular, as we look at verification, we're thinking about it meeting the specification level requirements, which are the solution-dependent requirements that are being satisfied. So this is, you come down the V on the left-hand side, come up with the solution-dependent requirements. So you come up with a solution. Here's the requirements for that solution, and that's what you're testing against or doing your V&V activities against. And I'm sorry, I will use the test and V&V really synonymously in this, and I realize that yes, test is a specific type of V&V. But forgive me, I'm old school, so I still kind of get them mixed up a little bit. Or I should say not mixed up, but at least I tend to use them synonymously. So the key is that you're trying to prove that the solution was or is being built according to the agreed requirements. That's the whole idea. And of course, we have definitions like unit testing or developmental test and evaluation really apply to this type of activity, this verification side of things. The validation is where you're now at the customer level, the stakeholder satisfaction is trying to be shown with this so that it really meets the real operational need. That's what you're really trying to address here. So this should be, hopefully you were given solution independent requirements or you derive solution independent requirements at this stage. And so those are the ones being satisfied. Again, oftentimes that's a lot of what happens in our architecture development. We're creating these kinds of requirements. And usually these are performed at the enterprise or the systems level at least. Usually it's the system of systems level, the enterprise level, that we're really doing a lot of this kind of V&V work, making sure that if you're bringing in a new system, that it works with the rest of the systems that are there and available, and it will interoperate properly. The key in the process of validation is to make sure that the system is going to ultimately be accepted, part of the solution that becomes in the target environment. And that's those important words, the target environment. So in other words, this is actually going to work where it needs to work, and it's going to meet the needs of the users. And remember, as you started this process, you may have come up with requirements early and things may have changed. And as time goes through, you may have been updating those requirement sets all the way through this process. So remember that you often have to be doing that as you go. So again, in the DoD parlance, we call this operational test and evaluation. That's really what you're trying to do in terms of getting operational suitability. Is one of the things you're particularly looking for. Is it suitable for the environment? So the life cycle, as we look at it, looks a lot like this. So we start with your current operations and maintenance activities, and we come in. So we start in that current state, and then we move to a future state of operations and maintenance, and that will be a different state. Do not expect that to be the same target environment. It very well might have changed significantly, particularly any major weapon system or any other major system you're developing. Is usually we're talking years between the beginning of this process and the end. And so obviously you have to be aware of those changes and be cognizant as you're doing this. In the architecture development phase, that's where you're starting often from very little information in terms of maybe it's a general needs statement you might get from users. You might have done a gap analysis and found that there was something that drove it. And so there's a process for doing this as you go through that, and then that gives you your point of the solution independent requirements, is this transition between the architecture development and system design. In system design is where you're going through more detailed development. You're coming up with a more of a solution-oriented aspect of this, and so you come with the solution-dependent requirements that transition into the hardware-software acquisition phase. Again, the whole purpose of this is ultimately to come up with that. For the systems engineer's job is to come up with the requirements that are going to be used to buy or build the actual system itself. Okay, and recognize that bottom part might take the most time. It may take a long time to acquire the hardware and software components, and then the integration and test phase happens as I'm coming up the V. And so again, I have that process there, and above that is the operative test and evaluation and transition. One of the things I tell people about architecture is when you're doing architecture, you're responsible for the requirements for operational test and evaluation, the ones that are going to be verified. What are those requirements? Those verification requirements. You're also responsible for transition, what the future operations and maintenance is going to be, and how it's going to be D&D'd. Demolished and disposed of. Those are important thoughts early in that life. That's why the architect's job is very hard. That plus the fact that often they're starting from little or nothing. And architecture has become a big deal over the last 20 years, and so that's why it's taken quite a bit. And often that occurs at the customer site, often with contractor help, which is perfectly fine. That's what the CETA job is actually. You'll notice these little icons in each of the stages. I'm showing a process, and this is a repeatable process that we've come up with coming down the V, and another one coming back up the V. And we'll talk to those processes here in the next slides. So the coming down the V process might look a little familiar to you, particularly those of us remember MIL Standard 499B. I've used this process now for, gosh, almost 30 years, I think. It seems like it's something on that order. Yeah, that's pretty doggone close. And so what this is can be executed a number of ways. The classic top-down way is starting with the requirements analysis, and then that's analyzing what are the requirements are above me. And now, obviously, if I'm in the first phase of the life cycle, my requirements may be just simply policy documents. I may not have a lot of detailed requirements to work from, but I do have a lot of constraints. I can almost guarantee I have a lot of constraints. So I want to do that as part of my requirements analysis. And then I use functional analysis and allocation to drive that next level of functional requirements. And the systems analysis and control piece of that is modeling simulation. And so I'm using that simulation. So I do the modeling in the functional analysis, and then my simulation helps me derive performance requirements. Particularly timing is one of the big ones, but many other factors come into play too. But timing is probably one of those critical ones. Because if you think about the primary things you're worrying about are quality, quantity, and timeliness. Those are your primary metric sets you're looking at. So those I can derive out of this functional analysis. When I allocate, I'm helping synthesize the actual solution. And so the synthesis step is then occurring in parallel with the functional analysis and allocation. You can't allocate to something if you haven't do it. If you don't do that. Same thing with the requirements analysis of the functional. I'm very often doing that in parallel as well. Because if you notice this, everybody looks at this as a waterfall, as a top-down process, but in fact, it can be executed bottom-up or middle-out. And I found that it's best used in different ways of what you're doing. So if you're in a situation where now I have as-is architecture, the documentation is so out of date or it's so lost in the history of the system, and you want to try to understand what it's doing today, really functionally, you would go look at it and go back and derive what the functional elements of it, what am I doing functionally? And then from that, derive a set of requirements, okay? That set of requirements then can be flowed back down into a new, changed functional analysis to say, well, how do I want to change the processes? How do I want to change how I do things? And then particularly that will be influenced by new technologies and new types of things as I synthesize the new solution. And so you notice this has to be a very iterative process. And in fact, it shows it that way, that the lines are showing that feedback loop from each of the other processes. And in fact, if you go back to the original 499B representation of this, all this was in a bubble, and you start at the higher level with a set of requirements, and at the bottom level, you came out with specifications, which is, of course, the requirements for the next phase of the operation. So if I go back to here, again, as I'm doing this, I'm deriving, I start at that top with the requirements for maintenance and things, and then bring them down into the cycle, and I'm creating specifications that are then picked up in the systems design phase as my next level. Okay, so again, hopefully you all understand this. This is a very fundamental thing about systems engineering, but a lot of people lose sight of this as they're in the middle of it. Particularly these days with model-based systems engineering, people pushing a lot about modeling, without recognizing what they're doing. They're trying to derive the functional requirements, and if they do the simulation part of it, they'll also have to derive performance requirements for the system. So coming up the V, we have another process that's just as important, and systems engineers play a huge role in this, if not actively executing all of these elements. At the top is IV&V planning, which occurs at the beginning of the life cycle and translates all the way through the life cycle, okay, to the end. Because you're always constantly planning and adjusting your plans. I was an experimental nuclear physicist, and we'd run experiments. You'd go down a path and then find that that was a blind alley. You reset and readjusted what you were going to do, the runs you were going to take, whatever you were going to pursue. And that's true in test and evaluation too. You'll find that you'll go down a variety of paths. Once you find you're successful in one area, you can just move on to the next one. So planning is happening all the time. As the design is being developed, particularly at the detailed level, you want to make sure you're monitoring, that design monitoring is occurring all during that hardware and software acquisition cycle, because you constantly want to understand what they have actually implemented. have they actually implemented? Plus, you have to have the ability to recognize when they come back and say, well, that was a nice requirement, but we can't do it. So what do we do now? So that happens, and that happens all the time. Okay, so that's not a once in a while thing. That does happen, and so you got to have that ability to monitor the design, update it, change, see the impacts of it. That's why we do traceability, right? We do requirements traceability because we're trying to trace back, well, what's the impact of that? How is that going to impact the overall design, and how is that going to impact the customer's requirements? You know, can we still meet the customer's need? You know, these are things they're fundamental with that design monitoring that occurs. Also integration. So you're going to be integrating. You're going to be bringing those up together. And so as you start piecing the pieces together and seeing how they interoperate as subsystems and into the actual system itself, you want to do that integration look and understand and conduct also in parallel some V&V on those cycles. So again, a lot of times the verification part of that is happening in the design engineering phase, and then the validation occurs in an operational environment. Oftentimes with software these days, since it's heavily software intensive system or a software product, we'll do a lot of the integration and testing together. And so that happens in rapid concurrence. Okay, so preparing for V&V. What do we need to do and how can we do it? So first of all, again, we have to recognize that as we're doing each of these steps, that question mark is answered by the set of requirements that's coming across. And that's why the V model is actually thought about as a key model, is it reminds us as we're coming down the V, we're creating the requirements for the things we do coming up the V. So again, that's why the lines of the question marks, the arrows of the question marks are there. So what do we need? Well, first of all, we need an ontology that includes V&V information, because if you're not going to capture the information early in your design, you're probably not going to be thinking about V&V. So we need to do that and make sure that's part of it. We also have to have verifiable requirements and or verification requirements. Now, in the old days, we used to have a specification, and there was a section 1, which was kind of a scope, that was the more background overview kind of thing. Then you had the scope section, you might have scope and then references, depending on which standard you're looking at. So those are the two first sections. Section 3 was your requirements section. It was the one that had the detailed requirements for the system. But section 4 was the verification requirements. And so that's usually how we constructed specifications. Well, you know, people do it a little more ad hoc these days, but still ultimately I have to have either verifiable requirements, in other words, the requirement itself is verifiable, or I create a verification requirement, which will be a specific requirement on the how I'm going to verify. And depending on what works best for your organization and where you are and what level of formality you need, that's part of it. And then last but not least, you also need a plan. Like anything else, if you don't have a plan, you're going to miss a lot of important activities. So it's important to do all those things and understand that for how to conduct their activities and report the V&V results. So, okay, great. You all know this stuff, I'm sure. Most of this stuff is pretty pro forma, but we want to make sure the folks who are new to it know it as well. Okay, so let's get into LML and how it can help us. So LML is a lifecycle modeling language. It developed a simplified schema. These are the elements of the schema. The actions are functional element. Artifacts are documentation kinds of products. Assets are physical. Characteristics are attributes of anything. Measures are the specific subclass that give you your metrics location. We have a couple of type of connections types. One is a conduit, which is a physical pipe of some kind. And it has capacity and latency associated with it, and then the logical side of it. So that's logical would be a relational kind of thing. Cost is an independent variable and an important one in this ontology. And then of course we capture decisions, input outputs with the flow information, locations, risks, statements, and requirements. Of course, a requirement is a subtype of subclass of statement because it has quality parameters to it. and then time, so it can capture schedule. This is pretty good. This gets us most of what we need. But what we found when we did Innoslate was we had to extend it a little bit. So we created a new subclass of action called the test case. Our test suites, which are the packaging for this test cases, are actually artifacts, okay, in the ontology. So that's our container for statements and requirements, but it's also the container for test cases. So the only thing we had to add was this thing called the test case, which we made as a subclass of action. Kind of makes sense. I'm going to do something. I'm going to perform an action, basically. So it makes sense to have a special type of that because we needed specific attributes that we're going to link to the test case. So again, you can discover other kinds of classes and attributes and relationships you may want to add for your work and what you're doing. That's fine. The whole idea of Innoslate and LML was to develop a way to easily modify the schema so that you get everything you need, capture all the information you need. But it gives you a nice 80% solution start. Again, here's the test case subclass of the action. You know, it's an entity that represents a set of conditions utilized to determine whether a system works as intended. The attributes that we've provided for it are here. Name, number, description is always any kind of class in LML uses those three as the common attributes. Action actually adds a couple other attributes. Duration is one of them, which is actually useful. You'll see in a minute. And then status has been added. That's an enumeration that takes us through different states of the test case, and you feel free to adjust those as you need to, by the way. If it isn't capturing all the states you want, fine, add to them. And those can then also be dealt with in workflow in Innoslate. So you can use that to help track your progress. And then the other attributes are actual result, expected result, and setup. So those all show up in it. In the test center, we don't show setup. That's left as an attribute, but you can always add a column for that if you want to in test center as well. Okay, so that's a very quick kind of overview of that ontology changes. Let's jump in and talk about what's a verifiable requirement. So this is our process for requirements analysis. So we go through this process, and in that work, we're decomposing the requirements that come in. And again, they come in from all sources and types of ways and different things. And we try to decompose those and create what are the requirements we want to refine and create and make them as verifiable as possible. We also have a couple of decision points as we go along. Is this going to establish some kind of critical issue? So I'm always looking for those kinds of problems. Is there a problem perhaps that's coming up? We do have an issue class in Innoslate as well, so you can capture things explicitly as an issue if you'd like and use that. Again, you might do some trade studies to resolve these issues. I heard a very good thing one day about systems engineering that what you want to do is define the trade studies that need to be done. That's the systems engineer's job. It's probably somebody else's job to actually do the trade studies. It looks like we lost an arrow here. So coming down from that, we're going to resolve any issues with the customer. So there should be an arrow between the box at the top and the options and the issues themselves. Okay, so the next decision point is is it verifiable? Now that's actually a home for all our quality parameters, but we specifically put verifiable in this process explicitly so that you could see and remember that that's probably one of the most important things you're doing in your requirements analysis, making sure that you have a verifiable requirement, okay? And that means something you can quantify and go off and measure to say, yes, we met that criteria, okay? So ultimately, again, you want to, if it isn't verifiable or any of the other things it needs to be, you want to work those changes, make sure you get it to be verifiable. but the output is those preliminary test requirements. That's what's going to the other side of the V from whatever level you're at. That's what's going to pop out. So those are what you're one of the major products that you're doing with this. Now the rest of this process is about allocation. Okay, so we're tracing the requirements to actions, assets, or measures, or test cases. As a matter of fact, that might be another thing you would add to that group of things. In fact, for this kind of work, test cases is probably the most important one you want to work to. We use traceability relationships in Innoslate of traces to for actions. Also, we have satisfied by, we usually apply to assets. And then we use verified by, which goes to test cases usually. Okay, so again, there's other ways to do that, and you can use the different classes of information relationships how you want to use it. But that's what we recommend. Okay, again, in all this process, I've got to identify risks into my risk management. Remember, the program management might be managing the risks, but they don't identify the risks, particularly not the technical risks. They might identify cost and schedule risk, although again, they may not even have any insight to that until the engineers say, hey, we're not going to meet schedule. And here's why. Of course, review, keep your customer in the loop. Again, I've got two places here I keep the customer in the loop. I think in that process, both those are important. Then updating your knowledge base. Now, obviously, as you're doing this, if you're doing this in a tool like Innoslate, you're doing all this stuff concurrently, and you're always updating that knowledge base. So we show it kind of as a sequential flow here, but in reality, this is happening massively in parallel as you're doing this activity. I've got a chart, I think later. Again, I'm going to get my presentations confused here, aren't I? Yeah, I did already. Okay, yeah, so we actually do have a timeline process that shows how parallel this activity really is. It's in the book. Okay, so what's the characteristics of a good requirement? Each requirement needs to be correct. Is it legal? Okay, complete, does it express the whole idea? Clear, unambiguous, consistent, not in conflict with other requirements. Verifiable, okay, provable within realistic cost and schedule that the system must meet the requirement, okay, really important. Of course, the others are traceable, feasible, which is it possible, modular and design. So you'll see those often used in it. I think we discovered that modular is actually overlapping with something else. So, but modularity is something, again, people want to hear about. So you can add that if you want to the requirements set quality score. So what makes a requirement verifiable? It needs to answer these questions. Can the requirement be met by analysis, demonstration, inspection, modeling, simulation, or test? Those are called the test methods. And in Innoslate, we've implemented those as labels, and we identify the requirement as having been meeting it by these different things. So in fact, you might use analysis and inspection for a particular to meet a particular requirement. That may be, so maybe you have to do more than that. Maybe you have to do all of them, by the way. There may be a requirement that's so important, you're going to do all 5 of them. So you might do that. And then the second is, will the user accept the results? Okay, that becomes a little bit more qualitative, but you can quantify those things. I was working with the people at the AFOTech and Air Force Operational Test and Evaluation Center, and they were actually using a psychologist to develop surveys, and they would go use the surveys to survey the user acceptance, the user suitability analysis, and then they would analyze that to use it to see if they really met the requirements. So they turn something qualitative into something quantitative. That's a typical thing we do in the V&V world. We'll take those qualitative user messages, things like usability. I love the usability one. That's a tough one. Is it really usable? To who? In what situations? You know, those are all qualitative things you need to quantify. Again, one of the things we got to be very careful about is using words like excessive and sufficient and resistant. You know, these things that are just make it very difficult to quantify. So requirements demo. So let me show you really quickly Innoslate requirements, and let me get this up, make it a little bigger for you. And also, make sure we're still working. So let me go to a requirements document. Yep, we've timed out. We time out on the cloud a lot more frequently than you probably would on your enterprise version. Okay, so let's pick our verification requirements document. And so this is now a set of verification requirements. So this is, we've gone and derived from higher levels these requirements. And so come down now to the point, these are the specific verification requirements. And the methods that we're going to use here are the labels. You see that here. And so you can see that there's a specific kind of test even being implied with some of these different verification requirements. So this is showing different aspects of things. Looking at the natural frequency, one of the things you worry about in natural frequency, and notice this said by this, the original requirement said it's going to be verified by analysis and test, and this was decomposed into two separately, analysis and test, so you could track them separately and trace them separately as you need to. What else can I say about that? Anyway, so this is the, one of the biggest problems you have, and this is for a spacecraft, is vibration. On launch, there's a lot of vibration. So you worry a lot about how you're going to deal with that and making sure that the vehicle won't break up. All the pieces don't fly apart. So this is one of those kind of tests. You're going to do things like that. So there's a variety of other tests here that were specifically referenced. This is out of a book, Applied Space Systems Engineering. If you're not familiar with that book, I highly recommend it. Anyway, so if you look in Innoslate here, you'll see the ST and Vs. And you see quality scores over here, the quality score, and then, I'm sorry, there's also a rationale field. So all those are here. So if you look at it, click in any one of them, it looks like I won at 75%. I'd click in and look at the attributes. And our NLP checker checks for things like clear, complete, consistent, design, traceable, and verifiable. Those are the ones it checks. It cannot check currently correct or feasible. Is it legal again, and is it possible? So we think we do need some help there. Anyway, there's various things it's finding. It might be some issues about completeness. It looks like this may need to be broken up. In fact, there's really two requirements in here, so this should be broken up. And then again, and the ambiguities are here too, making it difficult to verify. So appropriate and all. Those are almost always get you in trouble. So, but again, you can override these. You just would toggle the no to a yes, and it would give you the better value. Yeah, this original one definitely had some issues with it as well. So as you work through it. What else can I show you with this particular one? So, so the ST and V here. So let's click on that. And the relationships tab shows me what those are. So S stands for satisfied by, so this is satisfied by a specific test in this case. Again, normally I try to do this with something more physical. So again, depends on how you want to use it. Trace to is showing me is trace to another operational requirement actually. So that's one that it's tied to. And then this is showing you verified by. So these are some specific test cases that are in my verification capability. I'll show you that in a little bit. So anyway, so hopefully you see the different aspects of this, and you have the analyzed requirements quality, and show you how we derive the verification requirements. So let me go back to slides. And so now let's talk about developing the V&V plan using model-based systems engineering. So here's another process diagram. This is one of the ones coming up the V. This is our verification process diagram. And this talks about the different aspects of it, updating your test plan, verifying the requirements, inspection, test reports, capturing all those, identifying deficiencies, looking for risks associated with that. In software, we talk about regression testing. We do something very similar in hardware, where you build a little, test a little kind of approach, and that's really what regression testing is, essentially. I know I'm oversimplifying, but that's what it basically is. So again, develop the deployment plan also and test results. So obviously there's a lot of things going on in this stage. And so we want to, again, do things like the deployment plan, recognizing that's part of my effort as I'm doing this as well. Again, this may not be your process, not a problem. Again, this is just what we do. So to create a test plan is pretty simple. All you have to go to is into our new documents view and create a new document and choose the test plan option. And then there are templates. If you want a blank one, you can do that, and then you should put in your own. Another way you can do this is if you have a template already, you can import that template, identify this is a test plan document. You see the test plan document as a label. It's associated with the artifact. Once you do that, then it'll automatically show up as a test plan in that view. So what I'm going to do is show you that and a test plan, show you how we've used that for doing things. Okay, so let me go back to my, just actually close that window. Okay, there we go. I thought I deleted. I thought I'd closed the whole thing. Sorry. Okay, good. Okay, so go back to documents view. So again, if you're going to author this document, go to new documents. You come over, select what you want here for test plan document, and then give it a name. Test plan new, and give it a number if you'd like to. PP.2, and then I would go through and hit next. And then we have a CDC template with guidelines. It's the only one we have. Unfortunately, that was the one we could find. If you've got a good one and you want to share it with us, please send it to us through ShareSpace. If you want to know more about that, please email about that. So with guidelines, so let's look at the one with guidelines. So let's take a look at the CDC guidelines. Finish, and it pops me into the document view for this document. And these are the different aspects of it. You can see the purpose, compatibility testing, risks and issues, items to be tested, not tested, your approach, your test approach, some regulatory mandate criteria, things like that. So great way to start with something like this. If this meets your basic needs and all you want to do is iterate off of this, that's fine. If you've got your own already, like I say, it's very easy to import it. The part again that probably again might confuse people is these are just another type of statement. Okay, if you have the requirements documents have both statements and requirements in them, and so this has I believe these are all imported as just statements. Brought in as just statements. Now they are showing a decomposition of the parent. That's 1.1. So let's go to 1. If I look at 1, that's sourced by the new test plan. That's my artifact. So if I click on that artifact, I will go right to the artifact itself. And you can see what it is, and it has the label over here on the left. It says test plan document. So again, if you brought in your own through the import analyzer, you will have an artifact. It'll probably default to a requirements document. You change the label on the artifact from requirements document to test plan document, and automatically it's a test plan. Okay, so it's very simple to do. We'll show you one a little bit more fleshed out here in a minute. Let's get back to slides. So creating a test process or test case is something that's very simple to do. We like using our action diagram to model processes. That's what we use it for primarily. What's nice about this is that these actions, since the test case is a subclass of action, you can actually reuse both the test cases. You reuse the test cases as actions in an action diagram, which means then I can execute that action diagram. I can cost it. So it helps me with my timelines, create a schedule. A lot of the things you need for the plan, you can drive this way. And you notice that the input-output elements here, which is the parallelograms, are showing me key inputs and outputs that I need to create as I'm going through this process. So again, that's just a model of our process that we like. Now the key is making sure that it works. You can use simulation, and you can use simulation to help drive your actual testing as well. We are in the process of tying together some test tools that are used in the design engineering space for both hardware testing and software testing. So we can give you more detail of that offline. So let's just kind of walk through and show you what that looks like. So what we recommend is, we recommend you start creating your test center, test suites right away. So as you're developing those verification requirements, come up with what you think, how you're going to test it. So here's a thing like the structural test, looking at the structures. You probably have vibration testing, a lot of other things that will come with that kind of testing. So I'm sorry, this is the vibrational test right here, the propulsion module structural test. So here's looks like the test cases. So we have a test case. We show the test case itself, and this is a higher level, so there's sub levels below it. Expected results, actual results, and what the status is. So if it's passed, you can see that it met the requirement. And obviously I've not filled all those out yet, but the actual results, which again would be something I'd show, but we're showing you this as an example. And so there's different steps, and I believe I've set up, yeah, it's interesting. Set the different steps. There you go. So from not run, you have in progress or blocked. This should have showed me. So there's been a workflow that's been developed for this, but it looks like it's not completely done. Anyway, so this gives you the roll up of the status as well, so you can see at the different levels decomposition. And since this is hierarchical, you can kind of collapse or expand it as you need to, so you see the different aspects of it. Now, so these test cases also, again, are a subclass of the action class. And so what I want to do is be able to see it as an action diagram. So I select that top one, the acceptance test, select the action diagram for it, and I can see the different tests that I'm going to run. And this lets me see my test teams that are going to run them. And then it looks like the combined team is doing the overall payload module acceptance test. So this is just a test process that we put together. And so I can execute this using the simulator, and it'll execute in time to give me a timeline diagram and all the other things as well. Also understand that you can also model the system itself and run the simulator there to help see how you're meeting those requirements as well. So that could be your simulation. So you notice how we're tying together a lot of different things in one place. What's kind of nice about this is also, let's go back for a minute to the document, and let's go look at another test plan. And I think I have it handy here. Yeah, here. So here's where I start using this information, so I can embed in my test plan this actual process diagram. I can include my risk chart. And these are live charts and diagrams are in the tool. So, and you can build in tests, you can build in tables as well. There's just a lot you can do with this work. And so we've integrated all these pieces together so it's all seamless, easy to flow information back and forth as you need to. Okay, and then what I want to show, last but not least here with the test center. So here I got my test cases. What I want to do is say, well, okay, these are verified by, okay, they verify these different requirements. Okay, so I can look at that one by one here, but that's kind of a little painful. So why don't we look at the traceability matrix? So here's our traceability matrix. And if you remember, all my requirements started with VR. By the way, that's a pretty good thing to do with this kind of tool, is come up with these kind of mnemonics to use for sorting and querying. And then the relationship I want is verifies. And this shows me now, where the X's are indicating what I have established as the relationships between the actual test case itself and the requirement. And yes, I can modify each of those right here in this diagram. With Innoslate, all our diagrams are live. You can interact with all of them and do things with them as you want to. And so here, so I see there's X's here, but how do I know these are really good and these are the right set of things? So we have actually another NLP checker, and that's the traceability assistant. And so what that does is it's looking for commonality, common words and phrases and word types. Again, it's NLP, so it looks like things like markings and marked. You know, it can tell that those are the same thing. And so this is a very high probability one, because you look at it and you read the description field of the test case there on the left entity, and there's a lot of markings marked in there, right? Okay, good. That makes sense. But I also have a lot of X's that aren't highlighted. And in fact, with the suspect assist, it's going to highlight these as saying, hey, wait a minute, there's really nothing to connect these two together. Well, of course there isn't in this case, so I haven't written out what this test case is. So I either have to take that X out of the box, I want to take the X out of the box, or I want to flesh that out, that test case out in more depth. And that's probably what I would want to do here, to include steps that would include checking the markings. So I would do that as part of this. So again, in this case, the red may be an indicator more, rather than an error, more of an indicator of missing information. And that's important. Okay, so that's got that part of it done. So let's go next here. And so again, using the test center, and I've already touched base with this part. We talked about using that and how to set that up and make this part of your test plan. Other testing activities. So there's a lot of other things you do in testing, okay? But Innoslate can help you with all of them. So this is where you capture things like your test equipment and facilities. Those are assets, and you can capture what those are. You can build models of the facilities. You can build models of the test equipment. So there's a lot you can do, and maybe helping design your specific specialized test equipment. Your test organization, those are assets as well. You can capture that test organization, show that structure, and identify roles and responsibilities as statements associated with that. Obviously, you're going to look for risks all the way through this process and mitigation techniques for that. Criteria you want to find, any kind of test criteria. What are my metrics for saying I met the criteria for the test? Well, those I'd capture as characteristics or measures. A good example of a characteristic might be I just simply have a color, a specific color type I need to check for, and making sure that color was met. And so you'd have a color swatch. You'd compare against the actual color, say, yes, that's meeting the color. or if it's really that important to you, you may do something much more in-depth analysis than that. Otherwise, you might have metrics which have ranges. It can show the threshold and objective values. Again, so if there's variability, that's what you use the measure class for. A schedule, Of course, that's your timeline, and also part of this discrete event simulations and Monte Carlo simulators, we have the ability to output a Gantt chart. So you can do that as well. Cost, again, that's cost is a separate element. We have a work breakdown structure you can link to these processes as well. Use that as part of cost analysis. Data captures itself. So you want to capture that as characteristics or measures and times. We also have a variety of other ways of doing it using our XY plot now. You can bring in data and upload it as a chart, XY chart. Artifacts, again, there'll be all kinds of reports and other artifacts, outputs from the tools. Some of your design engineering tools may have detailed files. You can capture those as artifacts. You can also extend the schema for the test case to include, if you're going to have a file for every one of those, you just extend it and add a file attribute, and then you upload the file to each test case. That simplifies it a lot. So I wouldn't use the artifacts if I'm going to have that in every one of those test cases. So again, your choice how you want to use it. Location, of course, is always important. Where you're testing, custom test requires different test conditions, and so you want to look at that. And of course, any decisions, assumptions, issues, and tracking all those kinds of things as well. So I wanted to leave a few minutes for questions. And I do have a 3 o'clock, so I'm going to have to run. So very quickly here, V&V, I think we covered V&V in the early stages of life cycle, how to prepare for V&V, applying it to LML to V&V, talking about the verification of verifiable requirements, and your V&V test planning. So, do we have any questions?
Yep, thanks, Dr. Dam. We have a few questions. If you haven't done so, please send your questions to the panel on the right. Feel free to ask us as many questions as you have, and Dr. Dam will answer them before the time runs up. So our first...
or afterwards.
Or afterwards, yes, you could always do that. So our first question is, what would Agile look like in the V life cycle?
What would what look like?
A-G-I-L-E.
Oh, Agile.
Agile, thank you.
Okay, Agile. So Agile cycle, bring this back up. So the Agile cycle is something that's a much tighter iteration of the V. Actually, this is not the best. Let me bring up the V diagram. It's easier to talk to that. So, I mean, if you think about Agile, you go through many of the same stages. It's just there's not these big developmental parts of it. So it's sort of the same process you're going through. You're starting with requirements, you're building your code or something like that, and then you are verifying and validating the code. So it's a similar idea in terms of a life cycle. You have some kind of, so it's in a shorter timeline. So usually you're dealing with smaller amounts of things as you're doing the Agile cycle. In a scaled Agile framework, they have different steps and stages for that as well. So highly recommend looking at that for that part of the process. But we're very focused on the systems engineering part of it. Agile is usually being used these days for software development. Hardware development is very different. In software, you can do this build a little, test a little approach very well and very easily. In hardware, that's a little harder. It's more of a measured twice, cut once kind of environment. And so you have a different process set that you're working with that, some different tools. We are trying to automate all of that much more, but it's, we're not quite there yet. Next question.
Thank you. Our next question is, when running a simulation, how does Innoslate find the uncertainty parameters, triangular distribution, normal distribution, beta curves?
Okay, so really what we do is use the Monte Carlo for that purpose. And so we'd use that to go through different parts of it to look at those aspects. But also, I would say that more of that's going to come in from the design engineering side of things. And so you're going to be doing a detailed, maybe unit level design, unit level test, and bringing it up from that. And so that's where that information would come in. We have the ability then to match that. What I find in the early phases of the life cycle, I use a triangular distribution to use my engineering judgment for best case, worst case, and what's most likely to be. And then I refine that as I get more data from the design engineering space. And then when I'm doing simulation in the test and evaluation, I use all that data to put in the correct distributions.
Yeah. What is the difference between traced and verified by?
So again, we have used it in the way of trace to allows us to trace a requirement to either another requirement or an action. That's what we recommend using it for. Verified by, we're using pretty exclusively to go to a test case, okay? But again, you don't have to use them that way. That's just the way we use the ontology. You can do it however you want to do it as you're using those things. Just be consistent. And so one of the things that we've discovered as a best practice is to develop something called a conceptual data model. This is really the kind of thing you'd put in a system engineering management plan, where you'd say, follow this approach and use these terms and these relationships for these things. We highly recommend doing that. Also, it's the time you would determine to tailor the schema. You'd add relationships and classes and attributes as you needed to, and labels particularly.
My next question is, how can you create and reuse a template?
Oh, okay. So in fact, the templates in Innoslate are set up in a very simple way. In Documents view, you would go ahead and build your document. And once you're happy with the document, just hit the template button. And for the document type you're in, it will create a template in our tool for you that you can then use next time you do new documents for that type of document. And there are custom templates then available. We have more detail about that on the website.
Thank you. And our next question is, do I have to know LML to use Innoslate?
It helps. Helps a lot. It's like any ontology. You need to understand what the basis of the information is that you're capturing and how it fits, where the information fits, what bins the information fits in. It'll make using the tool a lot more effective. But yes, you can adjust. You can determine what the meaning of these things are for your needs.
Thank you. And then our next question is, can we see the ontology again? What is the origin?
Sure. So the development of the ontology, let's put that here. So this comes from the Lifecycle modeling language. It's in lifecyclemodeling.org. It's an open standard language. It was developed by a group of us derived from experience with a whole bunch of ontologies. We looked at everything we could think of out there and tried to simplify the number of classes of information so that it would be easier to understand where things go. What we found was that a lot of people use the same verb, but for some, you use different verbs for what's fundamentally the same thing ontologically. It has the same attributes and relationships. So action, for example, is an activity. It's also a task. So you can use these different terms. Capability is another one we use for that. So again, these are terms people use and differentiate. To us, kind of what was unnecessarily. Now, if you decide you want to differentiate them, it's fine. We've got labels for all those things, so you can separate them out as you need to. And if you decide that they really are different and you have different attributes and different relationships you need to add, then subclass action for that purpose. And that's what we've done with like test case. We decided that should be a subclass of action. I've got to run here because I do have a 3 o'clock that people are going to be waiting for me on. So do we hit all the questions?
Yeah, that's going to conclude our question and answer portion. If you have any more questions, don't be afraid to reach out. So thank you, Dr. Dam, and we would like to thank you all again for joining us today's webinar. Make sure to join us next time for our next webinar using Innoslate for project management on October 6th at 2 p.m. Eastern Standard Time. As always, we will also send out the recording slide deck to everyone that attended today. We'd also like to make a quick announcement for the save the date for the Model-Based Systems Engineering Conference taking place February 22nd through the 24th on the virtual platform AirMeet. MBSCCon is a conference dedicated to systems engineers who want to help achieve the digital future through ontologies. Learn more about MBSC, MBSC languages, ontologies, and more through our keynote speakers, invited papers, and panel sessions. Please keep on the lookout for more updates on MBSCCon as we approach the date. And please be sure to visit our website at www.mbsccon.haysummit.com. For more resources, we encourage you to visit our website and our blog, as well as connect with us on social media through the Innoslate user group or through Twitter using the handle @Innoslate. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar. Please enjoy the rest of your day.